My dear students, today we are discussing about what do you mean by significant figures are the figures on which we can rely. They are called as reliable digits and one non-reliable digit. Combined together they are called as significant figures. Let us take a weight of a boy by using three different weighing machines. In one machine his weight is 63.4 kg and the other machine it is 63.5 and one more machine he has seen his weight, it is going to be 63.2. So three different machines are showing different weights. But only you can observe that these two digits are not changing. They are reliable. We can rely on them. But this last final digit, this is a digit which is not same. It is changing from weighing machine to weighing machine. So totally one non-reliable digit and the remaining reliable digit combined together, they are called as significant figures. Okay. So here these are the rules for significant figures. The first rule is all non-zero digits are always significant. For example, whether there is a decimal point, whether there is no decimal point, here there are three significant figures, here there are four significant figures, here there are five significant figures, because they are all non-zero digits. There is no zero in that. Okay. Then what is the next rule here? So the next rule for significant figures is if zero comes in between non-zero digits, then it is also having significance. It is also reliable here. It is also significant if it is in between the non-zero digits. So here totally there are three significant figures, here four, here also four significant figures. Okay. The rule is if zeros are coming in between non-zeros, it is said to be reliable. Okay. So let us go for the next. If the zero is coming the left of the non-zero digits, then it is not going to be a significant figure here. Okay. So the rule is leading zeros or zeros before non-zeros are never significant. So there is no significance for these zeros here. So here there are three significant figures, here there are two, there is only one significant figures. Okay. So trailing zeros are significant if there is a decimal point here. Trailing zeros are zeros placed to the right of the non-zero digits, and if there is a decimal point, then it is said to be significant figures. So here even though zero is right side, it is having four significant figures. Even there are two digits, two zeros here after decimal point. That's why they are reliable, they are significant figures. Zeros are having significance here. So totally there are six significant figures here. Understood? This is another rule. The last final rule is powers are not having any significance. For example, if you observe, in exponential notation, this is not having any significance. So totally the significant figures are three here in both the cases. Powers are not having any significance. Okay. So this is about significant figures. Dear students, let me discuss a wonderful technique to solve the problems of dimensions. He is asking us to find out the dimensions of mass in terms of time, velocity and angular momentum. You have to do this problem by raising the powers of dimensions, but let me solve the problem in a different style here. So first of all, among all these, take angular momentum is nothing but mvr. So here, instead of writing V here, according to the problem, you have to write mcr. R is nothing but radius, which is nothing but distance, and distance is nothing but velocity into time here. Okay, so time. So just instead of R, you write ct. H is equal to mc ct. That is H is equal to c square t. But it's asking us to find out the dimensions of mass m. This implies that m is nothing but h. Okay, so send t to this side becomes t power minus 1, send c to this side becomes c power minus 2. So t power minus 1, c power minus 2 and h. So option is C option. Thank you. My dear friends, today we shall discuss about significant figures. So this is a previous year JEE Mains latest 2024 question here. So how many significant figures are there here? The first case, if you observe, zeros between non-zero digits are significant figures. That means these two zeros are having significance. So therefore total significant figures are 4. Now here, zeros between non-zeros are significant, but left of non-zeros are never significant. So this is not significant, but this is significant. So therefore it is having three significant figures. Here, zeros right side of non-zeros like 1 are also significant because they are right of the decimal point. So totally there are 6 significant figures here. Here, zeros in between and right are having significance, but the zeros left of non-zero digits like 1 are never significant. Therefore, the total significant figures is 5. So your answer is going to be the first option. Okay, so you can just see here, check it out. Thank you. Dear students, let us solve this problem by using power percentage trick. Everyone knows this is a previous year Question asked in 2024. Here powers are given, here percentages are given. Powers 4, 3, 2 I have written here, and percentages 3, 4, 5 I have written here. What is this technique here? Without even thinking much, you can solve this problem, which is nothing but just multiply these two. 4 3 is 12, 3 4 is 12, 2 5 is 10, and add all these. So 4 and 3. So 34% is going to be the answer. That's it. प्यारे बच्चों, ये जो है मेजरमेंट्स चैप्टर यूनिट्स एंड डायमेंशंस का प्रीवियस ईयर लेटेस्ट क्वेश्चन 2024 का जेईई मेंस का क्वेश्चन है. इसके अंदर जो है ना सिग्निफिकेंट फिगर्स पूछ रहा. तो फर्स्ट जो केस है ना, यहाँ पर दो जीरोस नॉन जीरोस के बीच में है, इसलिए उसकी वैल्यू है, उसका सिग्निफिकेंस है, इसका मतलब वो काउंट करेंगे. तो फर्स्ट वाले का सिग्निफिकेंट फिगर्स होगा 4. सेकेंड वाले के अंदर जब कभी भी जीरो नॉन जीरो के लेफ्ट में आता है ना, उसका कोई सिग्निफिकेंस नहीं रहता. तो इसका सिग्निफिकेंट फिगर्स हो गया 3. और यहां पर जो है जीरोस राइट साइड अगर आ गए और डेसिमल अगर है तो उसको सिग्निफिकेंट फिगर्स के अंदर काउंट किया जाएगा. तो इसका यहाँ पर जो है ना, यहाँ पर टोटल सिग्निफिकेंट फिगर्स 6 हो गए. तो यहाँ पर जो लेफ्ट है वो काउंटेबल नहीं है, जो बीच में और राइट है उसका सिग्निफिकेंस है. सो टोटली इसका सिग्निफिकेंट फिगर्स हो गया 5. So first option आपका correct answer है. My dear students, how to solve this problem? This is a problem of measurements errors, percentage error. Okay, he's asking us to find out the percentage error in resistance. You all know resistance is nothing but V by I. You can write like this here: delta R by R into 100 is equal to delta V by V into 100 plus delta I by I into 100. That's it. So delta R by R into 100 means what are you going to write now? So this is your find out here. Delta V means how much? So this part is going to be delta V. That is 5 by 200 into 100 plus is going to be how much here? 0.2 by 20 into 100. So it's going to be how much? It is going to be 2.5 plus 1, which is 3.5 is going to be your answer. That is 3.5%. Thank you. Dear students, let us solve this problem by using power percentage trick here. He is asking us to find out the percentage error in resistance where length and diameter should be the relation here. So you all know resistance is directly proportional to length but inversely proportional to square of the diameter of any wire. Okay. So if you are going to consider any wire here, this is the length and this is the diameter. So this is the relation here. What is the power of length here? Power of length is 1 and power of diameter is 2 here. Power percentage means first you have to write the percentage power here and again percentage here. Percentage for length and diameter is both is same here. It's going to be 0.1%. So you just multiply and write down what is going to happen. So this is 0.1 into 1 is 0.1%. Here 0.1 into 2 is 0.2%. You just add them, it becomes 0.3%. So your answer is 0.3%. First multiply the power with percentage and whatever you're getting, you just add them, you'll get the answer. Thank you. My dear students, మీరు ఇది ప్రీవియస్ ఇయర్ జేఈఈ మెయిన్స్ 2024లో అడిగిన క్వశ్చన్ ఇది చాలా ఈజీగా సాల్వ్ చేసుకోవచ్చు మనం పవర్ పర్సంటేజ్ ట్రిక్ యూజ్ చేసి. పవర్ పర్సంటేజ్ ట్రిక్ ఇక్కడ చూడండి, క్యూ ఈజ్ ఈక్వల్ ఇచ్చాడా, ఆ పవర్స్ మనం సపరేట్గా రాసుకుంటాం, ఆ పవర్స్కి సంబంధించిన పర్సంటేజెస్ ఇచ్చినాడు అది పక్కన రాసుకుంటాం. చాలా అంతే, ఎక్కువ ఆలోచించాల్సిన అవసరం లేదు, జస్ట్ మల్టిప్లై చేయాలంతే. సో 4 3s are 12%, ఇక్కడ 3 4s are 12%, తర్వాత 2 5s are 10%. ఈ అన్నిటిని యాడ్ చేస్తే సరిపోతుంది. సో 34% మీ ఆన్సరు. సో ఏమడిగాడు అక్కడ, క్యూ అడిగాడు, క్యూకి పర్సంటేజ్ ఎంత అంటే 34%, అంతే. చాలా సింపుల్ టెక్నిక్. ఇది ప్రీవియస్ ఇయర్ జేఈఈ మెయిన్స్ 2024లో వచ్చిన క్వశ్చన్ ఇది సాల్వ్ ఎలా చేస్తారంటే ఒకసారి చూడండి. ఇక్కడ సిగ్నిఫికెంట్ ఫిగర్స్ కనుక్కోమన్నాడు. ఫస్ట్ కేసులో తీసుకుంటే 2 జీరోస్ 2 నాన్ జీరోస్ మధ్యలో ఉన్నాయి కాబట్టి దానికి సిగ్నిఫికెన్స్ ఉంది. సో టోటల్ సిగ్నిఫికెంట్ ఫిగర్స్ ఇక్కడ ఎంత అంటే 4. ఒకవేళ జీరో నాన్ జీరోకి లెఫ్ట్ సైడ్ వచ్చింది అనుకోండి, దానికి సిగ్నిఫికెన్స్ ఉండదు, మధ్యలో వస్తే ఉంటుంది. కాబట్టి టోటల్ సిగ్నిఫికెంట్ ఫిగర్స్ 3 ఇక్కడ. సో ఇక్కడ తీసుకుంటే డెసిమల్ పాయింట్కి రైట్ సైడ్ 2 జీరోస్ ఉన్నాయనుకోండి, దానికి సిగ్నిఫికెన్స్ ఉంది, మధ్యలో ఉంటే ఎట్లా ఉంది. సో టోటల్ ఎంత సిగ్నిఫికెంట్ ఫిగర్స్ 6 ఇక్కడ. సో ఇక్కడ మధ్యలో లాస్ట్లో ఉంటే సిగ్నిఫికెన్స్ ఉంది, లెఫ్ట్ సైడ్లో వస్తే సిగ్నిఫికెన్స్ ఉండదు. సో టోటల్ సిగ్నిఫికెంట్ ఫిగర్స్ ఎంత ఇక్కడ 5. సో టోటల్లీ ఫస్ట్ ఆన్సర్ మీది కరెక్ట్ ఆన్సర్. థ్యాంక్ యూ. My dear students, let me use a wonderful short trick method to solve this problem. He's asking us to find out the dimensions of density in terms of force, velocity and time. Generally we use raising of powers method. I use a different style for solving this problem. I'll write density is equal to mass by volume capital V. And I'll also write force is equal to mass into velocity by time. Change in velocity by time here, okay? So mass is nothing but mass into acceleration, change in velocity by time. So mass can be taken as Ft by small v represents velocity, capital V represents volume here, okay? So here volume can be taken as L cube, okay? And length is nothing but distance is nothing but velocity into time, small v, okay? So now instead of v I will write this value, instead of m I will write this value. That is enough, you get the answer so easily. So m can be taken as Ft by small v and capital V can be taken as v cube into t cube. So t cube means t square is left. So d can be taken as f. This is v power 4 comes to numerator becomes v power minus 4 and t square comes to numerator become t power minus 2. That's it. So f v power minus 1 t power minus 2 is going to be our simple answer. Okay students, ఈ రోజు మనం ఒక చిన్న షార్ట్ కట్ నేర్చుకుందాం. ఇది యూనిట్స్ అండ్ మెజర్మెంట్స్ ప్రీవియస్ ఇయర్ క్వశ్చన్. సో యాక్చువల్గా డెన్సిటీకి ఫోర్స్, వెలాసిటీ అండ్ టైంలో రాయాలా రైజింగ్ ఆఫ్ పవర్స్తో. బట్ ఇట్స్ ఎ వెరీ కాంప్లెక్స్ ప్రాసెస్. ఐ హ్యావ్ ఎ షార్ట్ కట్. మన దగ్గర ఒక షార్ట్ కట్ ఉంది. డెన్సిటీ అంటే మాస్ బై వాల్యూమ్ అందరికి తెలిసింది. ఇక్కడ వాల్యూమ్ అంటే దానికి డైమెన్షనల్ ఫార్ములా ఎల్ క్యూబ్. ఇది వాల్యూమ్ అంటే క్యాపిటల్ వి. ఇట్ ఇస్ నథింగ్ బట్ వెలాసిటీ ఇంటూ టైం అనమాట. అంటే వాల్యూమ్ని వెలాసిటీ ఇంటూ టైం రాసుకోవచ్చు. క్యూబ్ రాసుకోవాలంటే. నెక్స్ట్ మనకు తెలుసు ఫోర్స్ అంటే మాస్ ఇంటూ చేంజ్ ఇన్ వెలాసిటీ బై టైం. అంటే మాస్ అంటే ఏం రాసుకోవచ్చు మనం? Ft బై వి రాసుకోవచ్చు. వి అంటే వెలాసిటీ. సో ఈ వాల్యూ ఇక్కడ సబ్స్టిట్యూట్ చేస్తే సరిపోతుంది. మాస్ ప్లేస్లో ఏం రాస్తాం మనం? ఫోర్స్ బై ఫోర్స్ Ft బై. తర్వాత వాల్యూమ్ ప్లేస్లో ఏం రాస్తాం? v క్యూబ్ t క్యూబ్. t క్యూబ్ క్యాన్సిల్ అయితే t స్క్వేర్ వస్తుంది. d f v పవర్ 4 పైకి వస్తే v పవర్ మైనస్ 4. t స్క్వేర్ పైకి వస్తే t పవర్ మైనస్ 2. సో ఇది ఆన్సర్ అన్నమాట. మై డియర్ స్టూడెంట్స్, హౌ కెన్ యూ సాల్వ్ దిస్ ప్రీవియస్ ఇయర్ ప్రాబ్లమ్ ఇన్ ఏ డిఫరెంట్ స్టైల్ హియర్? లెట్ మీ సీ హియర్. He is asking us to find out the surface tension dimensions in terms of energy, velocity and time. It's very simple. You know surface tension is nothing but force by length. Here energy or work done is nothing but force into displacement. Force is nothing but energy by length or displacement is same. So instead of force I am going to write here energy by length. Already one length is there. Energy by length means L square. And you know length or displacement is nothing but velocity into time. Okay? So length is nothing but velocity into time. Length is nothing but displacement. That's it. So therefore surface tension is nothing but E v power minus 2 t power minus 2. E v power minus 2 t power minus 2 is going to be your answer. My dear students, today we shall discuss a wonderful short trick for this problem. All this is asking us to find out the dimensions of length in terms of force, acceleration and time. Okay, generally we use this method, but let me solve this problem in a different style where you will feel wonderful. That is asking us to find out the dimensions of length. Now just see here, it's very simple. Acceleration dimensional formula is nt power minus 2. That's it. He's asking us to find out the dimensions of length. Length is equal to a, t this comes to this square becomes t square. Your answer is ready. That's it. My dear students, today we shall discuss a wonderful short trick for this problem. All this is asking us to find out the dimensions of length in terms of force, acceleration and time. Okay, generally we use this method, but let me solve this problem in a different style where you will feel wonderful. That is asking us to find out the dimensions of length. Now just see here, it's very simple. Acceleration dimensional formula is nt power minus 2. That's it. He's asking us to find out the dimensions of length. Length is equal to a, t this comes to this square becomes t square. Your answer is ready. That's it. My dear students, let me solve this problem of previous year NEET 2024 in a completely different style here. Let me discuss about that. You all know, according to law of homogeneity, these three terms are having same dimensional formulas. That means alpha t square is equal to beta t. These two terms are having same dimensional formulas. If you cancel these two, what is left now? Alpha t is equal to beta. Okay, as they are having same dimensions, he is asking us to find out the dimensionless physical quantity. Just if you divide alpha t by beta, It is going to be dimensionless. Therefore, B option is going to be the correct answer. Without using dimensional formulas, we have solved it. My dear students, let us solve this problem in a different style. You can just see he's asking us to find out the energy in terms of momentum, area and time. The simplest way is Einstein's mass energy equivalence formula will help you to solve this problem. E is equal to mc square. C is the velocity of light. Here, E can be taken as mc into C. E is equal to pc. What is C? Velocity. Mass into velocity is nothing but momentum here. So now can I write like this? I will write here velocity is nothing but Lt power minus 1. Area means L square. L means square comes to this power, this side becomes A power minus A power 1 by 2 here. So we can write here E is equal to P. Here C can be written as, instead of L, I will write A power 1 by 2. This part if I write here, it is going to become A power 1 by 2. T power minus 1 is going to be our simple answer. My dear students, today we shall discuss a wonderful short trick for this problem. What is this? Is asking us to find out the dimensions of length in terms of force, acceleration and time. Okay. Generally we use this method, but let me solve this problem in a different style where you will feel wonderful. That is asking us to find out the dimensions of length. Now just see here, it's very simple. Acceleration dimensional formula is Lt power minus 2. That's it. He's asking us to find out the dimensions of length. Length is equal to A. T this comes to this square becomes T square. Your answer is ready. That's it. My dear students, let me solve this problem in a different style in a shortcut method here. He's asking us to find out Young's modulus in terms of force, acceleration and velocity. Okay, and you all know Young's modulus is nothing but stress by strain. Strain does not have any dimensions. Young's modulus is equal to force by area. Area is nothing but F by L square. Area means L square. Okay. Now here acceleration is nothing but change in velocity by time. Acceleration is given as capital A. So change in velocity by time. Okay. So here, but here, what are you going to do here? Instead of so my dear students, here we can write time is equal to velocity by acceleration. Time is equal to velocity by acceleration. So this you remember. Next thing you have to do here is force by length. Length is nothing but displacement. Displacement is nothing but velocity into time. Okay. So now force by velocity is the time you have to replace here. Time we can take it as V by A. So we are going to write Y is equal to F by V square. So T can be written as V square by A square here. That's it. This implies that F, A square comes to the numerator. This is V power 4 come to the numerator become V power minus 4. Okay. So therefore this is going to be your correct option. Thank you. My dear students, let me solve this problem in a different style in a shortcut method here. He's asking us to find out Young's modulus in terms of force, acceleration and velocity. Okay. And you all know Young's modulus is nothing but stress by strain. Strain does not have any dimensions. Young's modulus is equal to force by area is nothing but F by L square. Area means L square. Okay. Now here acceleration is nothing but change in velocity by time. Acceleration is given as capital A. So change in velocity by time. Okay. So my dear students, here we can write time is equal to velocity by acceleration. Time is equal to velocity by acceleration. So this you remember. Next thing you have to do here is force by length. Length is nothing but displacement is nothing but velocity into time. Okay. So now force by velocity is the time you have to replace here. Time we can take it as V by A. So we are going to write Y is equal to F by V square. So T can be written as V square by A square here. That's it. This implies that F, A square comes to the numerator. This is V power 4 come to the numerator become V power minus 4. Okay. So therefore this is going to be your correct option. Thank you. My dear students, let me solve this problem in a different style where he is asking us to find out the dimensions of mass in terms of force, velocity and time. Let us not do in this method, we go for a different style here. What is that? You all know mass is equal to force by acceleration, is it? Okay. And you all know acceleration is nothing but change in velocity by time. That's it. So m is equal to F. Change in velocity by time comes to the numerator. Therefore, mass is equal to F. V power minus 1 and T. That's it. Okay. So D option is going to be your answer. My dear students, let us solve this problem in a different style. Let me discuss What is that style here? He's asking us to find out the dimensions of force in terms of pressure, velocity, and time. Now just see here, how can you solve by using a different style here? So we can write here, force is equal to pressure into area. Okay, pressure into area, because pressure is equal to force by area. Force is equal to pressure into area. Here, area can be taken as L square. And you know, length is nothing but displacement is nothing but velocity into time. That's it. So instead of A, we write L square means V square T square. That's it. So this is going to be our option. Thank you.